Hello friends, welcome back to our CCNP 350-401 ENCOR series. We welcome you all to our YouTube channel, Network for You. If you remember, we are doing the spanning tree protocol. We done some part. Now we are going to look some more detail. We are going to check how the root port is selecting. If you remember, if you see here, let me show you in the packet tracer here. Which switch is a root bridge? First of all, we will check that one. Let me show you here. If I go here and I write show spanning tree VLAN 1, and if you see, this is the root port. The role of this interface is root port. So how it is selected as a root port? So this is a switch. Which switch I open? Switch 0. So this switch. So this switch port is F0 by 1. If you see here, F0 by 1. This one is treating as a root port because it is directly connected to root bridge, and this is the root bridge. If I show you here, let me show you, show spanning tree VLAN 1. Okay, and if you see here, this switch has a root. Let me show you. Yeah, this bridge is a root. So this one is a root bridge. So let me write here, this is the root bridge. This is a root bridge. So I am saying this is a root port. This port is a root port. As we discussed before, whatever port is going to the root bridge directly connected, that will be the root port, and this one also the root port, and this one is a designated port, this one also designated port, and opposite to designated port, maybe we have root port or maybe we have block port. Okay, this one we already discussed and we know this one. If you see here, this port is a root port. Why it is root port? Because it is directly connected to root bridge. This is a root bridge, and this is a block. Depending upon the MAC address, one is having the issue, like this is the root bridge, and this MAC address is lower than this one, so that's why they disable one link. We already discussed this one, we know that one, right? So in this video, what we are going to discuss, we are going to discuss selection of the root port, how this root port is selected. So what we need to remember, shortest path to the root bridge. This is the shortest path to the root bridge. This is a root bridge. So this link is a shortest path to the root bridge. That's why this is selected as a root port. Here also, this is also shortest path. That's why it is selected as a root port. You need to remember this one. Also, typically of the cost, depending upon the cost, how much cost it will take for going here, and how much cost it will take from going from here to here. Like that, cost also going to be calculated. Depending upon the lowest cost, it will move. So let me show you cost here. If you see, this is a cost 19. Okay, for this link and this link we have cost 19. So let me write here cost 19. So here is 19, again here is also 19, and here also 19. If you want me, let me show you. I will go inside the switch. I will write show spanning tree, and let me write here. I will go in the enable. I will write here show spanning tree VLAN 1, and you see, this is the cost for this port F0 by 1 and F0 by 2 is 19. Why this cost is 19? Why it is not 100? Why it is not like a different cost? Because this is depending upon the speed, like which Ethernet network we are using. We are using fast Ethernet, that's why we have the cost 19. Let me write here cost detail, so you will remember. You need to remember speed. If you have the speed like 10 Gbps, 10 Gbps, if you have the speed 10 Gbps, then the cost will be, you need to remember, cost will be 2. If you have the 1 Gbps, then the cost will be 4. If you have the speed 100 Mbps, then cost will be 19. And if you have the speed 10 Mbps, then you have the cost 100. So fast Ethernet is having the speed of 100 Mbps, that's why it is 19. If we use Ethernet, it is having the speed of 10 Mbps, so cost will be 100. So in this case, we are using fast Ethernet. If you see F0 by 1, F0 by 1, F0 by 2, this is a fast Ethernet. F0 by something by F0 by 0, something we are using, because we are using fast Ethernet. So what we can say, this is a fast Ethernet, that's why the cost is 19. So whenever we are selecting the root port, it is checking the cost. Example, if any one want to go to the root bridge, so they will, if they go like this way, it will be 19. Okay, so this is the 19. If anyone want to go to the root bridge from here, the cost is 19. Okay, but example, if anyone want to go from here, example from here, so how much the cost? Let me erase and do again. If anyone want to go from here, if let me change the color also, if any guy want to go from here to the root bridge, this will be 19 and this will be 19, right? 19 plus 19, 32, right? 30, let me 38. Okay, did you understand or confusion what I am saying? If anyone want to go to the root bridge, every traffic need to, all the packets, all the frame need to pass through the root bridge. So this is the root bridge. So all frame need to pass from this one. So when the frame is going from here, it is taking 19 here and 19 here. If we add, it is taking the cost as 38. Why I am saying this is 19? Because this is 19 is nothing but because we are using a fast Ethernet. If we are using 100 Mbps link, that is a fast Ethernet is supporting this 100 Mbps, then the cost will be 19. If you use Ethernet, then the cost will be 100. Okay, so here cost will increase, so that's why we are not taking this one. That's why this port is disabled also. And if you see, we from here 19 and here 19, so this will be less compared to this one. If the packet, if anyone want to go from here, if it is going like this, then here will be 19, again here will be 19, then we will have 38 again, so the cost will be more. So to overcome with these types of issue, they disable this one. In simple words, you need to remember what you need to remember. You need to remember the when the frame need to go to the root bridge, they are checking the shortest path and they are checking the low cost path, and the cost is defined as per the speed. This is a speed and the cost is defined like this. And whatever the like port is connected directly to the root bridge and that is having the low cost, that port is that port is nothing but root port. And if you check here also, this is directly connected to root bridge and it cost is low, that's why it is a root port. This port is root port, this port is root port. Okay, so this is a just explanation about the root port, how we are saying this is a root port or not. If you want, let me show you. If I type here, if you see this one, this port F0 by 1 is nothing but root port. This is a root port. Root port always in the forward, and designated port also in the forward, means status will be forward. We are going to discuss the status. We have status listening, learning, blocking, like that. So we are going to check that one also. Now you need to remember root port is nothing but forward port. Root port is always be in the forward, and the root port is how we will get the root port means root port will be directly connected to the root bridge with the shortest distance with the low cost. You can say like this. Okay. So if you want, let me show you in the GNS3 also. This is a GNS3. Let me take, this is a 2 switch. I connected with the Ethernet. This is a not fast Ethernet. This is only normal Ethernet. Ethernet will be having the cost 100. If you see, this cost is 100 because Ethernet speed is, what is the Ethernet speed? This one, 10 Mbps. So cost will be 100. So here will be cost will be 100. And if you check, one port is a root port, and all other ports are the designated port, this one. And if you go for the switch one, because switch 2 is the root bridge. If you see which one is the switch 1 is the root bridge or switch 2 is the root bridge. Let me check here. I've read spanning tree, show spanning tree VLAN 1. If you see here, this bridge is a root bridge. So this one is the root bridge. Switch 1 is the root bridge. I connected one link, that link port, this one, whatever is it is showing. I have this many link, this many interface I have in the switch, but I am not using. I am using only one E0 by 0. Let me take one more link and connect here. Example, I will connect E0 by 0 and E0 by 1. Here also E0 by 1. So I am using two links. So one link will be disabled after some time. I am using E0 by 0 and I am using E0 by 0 and E0 by 1. I am using these two, but here they will show how many they have. It will show all. So what I will do, I will disable. So no confusion for us. Let me go in the global configuration mode and I will write interface E0 by 2 to -2 range. I will write interface range, then E If you want to disable, we can disable also, because maybe you face the confusion. Like example, if you are getting so many ports, you will have the confusion. We are using only this two, E0 by 0, E0 by 1, but it is showing this all. This all are not using, but they have this is present in the switch. That's why it is showing that one. If you don't want to see this one, then you can select this or write in the range. Like example, I am writing E0 by 2 to E0 by 3, E0 by 2 to E0 by 3, this one, and I can put comma and I can write E0 by this one, E1 by 0, E0 by 2, like this. I can go inside and I can write no shut down. Like if I write shut, then that port will be disappear. Example, let me show you. Show spanning tree VLAN 1. So that port will be shut down. If you see what port we remove the, let me see here, E0 by 2, E0 by 3, E0 by 2, E0 by 2 is gone, E0 by 3 also gone. Only we have E0 by 1, E0 by 0 and E0 by 1. These two ports we are using. Okay, you try to see this two port only now. Whenever we are discussing in this class, you observe only this two port. If you want to remove, we can go to this interface and write the shutdown, so it will go. But no need to do now, it will take long time and it will video become lengthy. So I will keep this as it is. Just we need to see this two, E0 by 0, E0 by 1. So if we go here in the switch 2, I will write show spanning tree VLAN 1. If you see here, I have this two switch. Okay, one is in the forward, another one in the block. Okay, which one is forward? E0 by 0 is forward, another one E0 by 1 is in the block. So why E0 by 1 in the block? Because they are creating the loop. We have two links, that's why one will be block, and this will be the root port. Why this is root port? Because this is directly connected to the switch and it is having the low cost, that is 100, because compared to all link this is same. So we can say cost will be 100, and this is directly connected to the root bridge. That's why it is a root port. And why this is disabled? Why this port, that is E0 by 1, is disabled? If you remember, let me remove this and take this one. See here, this E0 by 1, E0 by 1, this port is disabled. This is disabled, the below one is working. So why this is disabled? If you check here, you can see, first of all, they will check the cost. Both are having the same cost. Then they will check the priority. Both are having the same priority. Then they will check the number. Which number is higher, they will disable that port. So this one is having the higher number. This is a 2. That's why they will disable. But they will not check in this switch. They will check in the opposite. So they will check in this switch ports detail. So what they will do, they will, let me go here. They will go in the switch 1. They will check here. This one and this one. They will compare these two. Let me select this one, this two. They will compare these two. They will check, this one is the cost is 100, this one also cost is 100, this is the priority, both priority is same, they have the number 1 and number 2. So this is the number 2, so that's why they will disable. Okay, that's why they will disable the opposite link of the switch. If you are confused, let me show you in the packet tracer, you will have the more idea. See here, let me close this one. Let me open the packet tracer. If you see here, let me take two switch. Let me take one switch here. Switch here. This is a switch. Okay, this is another switch. And now I will take this one. I will take this cable. I will connect E0 by 0 to. Here I am connecting to opposite. E0 by 0 is connected to E0 by 2. Opposite. Okay, to explain you. And again here E0 by 2 is connected to E0 by 1. Okay, I am selecting to the opposite one. So this is a F0 by 1 is connected to F0 by 2, and F0 by 2 is connected to F0 by 1. So now you will have more idea. Now I will go inside this switch. Okay, and I will write here like enable, then show spanning tree VLAN 1. So if you see here, this port, this bridge is a root. So this one is the root bridge. This one is the root bridge. So let me rename root bridge. So RB I will write, and this one is the non-root bridge. Okay, so NRB, non-root bridge. So if you see in the non-root bridge, the port is disabled. F0 by 1 is disabled. So why F0 0 by 1 is disabled? Because what they check, first of all, they check the COS. First of all, let me go here and show you here also, then we will compare. First of all, they will check the COS. Let me move this up so you can see that one. And here, first of all, this one non-root bridge. So let me go here. I will write no and then enter, then show spanning tree VLAN 1. Now if you see here, first of all, they will check the COS. COS means they will check here the COS for the board interface is 1919 same. Then they will check the priority. Priority is same. Then they will check the port. So which port is having the highest number? So this port number is highest. So they will disable this one. But they will not check for this switch one. They will check the opposite one here. They will check here, and depending upon that one, they will block the opposite one. So if you see, this port is the higher one. So this should be F0 by 2 should be blocked. But it is not blocked. Why? They are not checking the same switch. They are checking the opposite. So they will check this one. And then depending upon this one, they will block the opposite one. So what I will do, I will go here. I will open this switch. I will open this switch. Okay. And here, what I will do, I will write here show VLAN 1, this one. If you see here, they are comparing which port we need to block. They will check the COS. Both COS are same. Both priority are same. Then they will check the number. They are checking this F0 by 2. F0 by 2 is number is high. This is low. So they will keep this okay. They will disable this one. So which one they are saying? F0 by 2. So F0 by 2. This one is F0 by 2. So whatever port is connected to F0 by 2, that port of the other switch is going to disable. So that's why this is disabled. Okay. So we are checking in this switch. Just remember, when we have two switch, example, I have two switch. I am connected the 4 link, and this is a root bridge, and this is a non-root bridge, and this port is working, this one, and all other are working from this side, because root bridge, all the ports of the root bridge will be working, and all the other switch, that is non-root bridge, only one link will work, other link will be down. So why this is down? Why only this one is working? Means they will have the they will check in this switch. If we are blocking in this switch, then they will do in the opposite. What is opposite? That is connected to this switch. Which switch is connected to this switch? They will check in that switch. What they will check? First of all, they will check COS. If the COS, which COS is high, they will block that one, that port. Example, this is F0 by 0 and this COS is high, then the opposite which is connected here, example, if I have connected F0 by 3, then this is going to be blocked. Okay, but if they check here, the COS is here same, both are having same COS, then they will check the priority. If anyone is having the high priority, they can block, but the priority also same here, so they will leave. Then they will check the which number is having the high number. So number will be remain same, it will not increase. Like port number, example, if you see switch, you have the switch and you have the ports here like 1 2 3 4 like this inside the physical switch, so that number will be 2. So this interface opposite, whatever switch is connected to this interface, that port need to be block. So they will check this switch, this port is connected to this switch opposite directly, that one we need to block this one, so it is blocked here. Okay, any confusion, any issue? If you are facing any confusion, any issue, you can tell me. Okay, no issue, right? You can write in the comment, we will do again if you have any confusion. So what we learn the root port, how we select the root port, and why this one is not selected, this is why it is blocked. We learn that one also. Now we can say STP port status. STP port status, we have the STP is having the port status. STP spanning tree protocol port status. Let me write status. We have first one is listening. Listening is having 15 seconds. You need to remember, this is interview question also. And learning is having 15 seconds. And also then blocking blocking is having 20 second. Okay, so the again we have forwarding is not having no limit, means forwarding they will forward. And we have disable is also not having any limit. This three is important, you need to remember. Listening is having the 15 second, and learning is having the 15 second, and blocking is having the 20 second. When you connect the switch, example, if you connect the switch, then this port will go in three state. First they will start listening, then learning, then forwarding. I am going to show you in the GNS3. Okay, this is the two switch we have in the GNS3. Let me open the GNS3 here. Let me close this switch and again open this one, and now I open, and let me go in one switch and enable the like debug command. I want to debug some what I can say, I want to enable the debug command, so we can say which states they are going. So how we will debug? If you want to debug, you can write debug. Let me write here. It is working, or yes, I can write debug and spanning tree events. Okay, so now debug is on, so whatever event is happening it will show. If you see here, let me make zoom big. If you see here, you have here port is in the forwarding. Okay, port is in the forwarding. Before it is having different. I started here, so let me do again something. This is a switch S1. Okay, so I will disconnect, or maybe I will switch off and on one. This is the in switch 1 what I done. In switch 1, let me delete this one also. In switch 1 I type debug spanning tree event, so whatever events is happening I am seeing here. So what I will do for the switch 2, I will close, and again I will start. So now I will go in the switch 1, and we will see the whatever happening here. If you see here, the listening state, it went in the listening, then we will have the learning. 15 seconds it will take for listening, then it will take 15 seconds for learning, as we discussed. Here listening, here learning. If you see here listening, here then it moved to the learning. It is going in the states, different state, whatever states we have. Now again it is going to move to forwarding. So if you see, it is moved to forwarding. First they have, let me write here. If you see listening, then it will move to learning, then it will forward. So it will take 15 seconds, and it will take 15 seconds. Then after that one, it will start forwarding. Okay. If you have any confusion, you can tell me, no issue, right? If you face any confusion, this one is a little theoretical concept. You will face some boring or something, but this is very simple and very easy. Know that we don't have that much configuration here. We have only some concept we need to understand. In this one, you need to understand the concept only. We don't have many configuration, just you need to understand what I am saying. Listening is taking the 15 second, and learning is taking the 15 second. So whenever you switch on the switch, whenever you take any switch and power on, it will take 15 second, and again 15 second, that is 30 second it will take to send your frame. Example, if you are pinging from one PC from this place to this place, and just now you switch on the you power on the switch, then it will take 30 second to go from learning and listening, learning, like that. If the switch is if the port is in the block state, then it will take extra 20 seconds, because we have listening 15 and learning 15, and for the block we have blocking 20. So we can say this is 20, so total time will be, this is 30 and 40 50, so we need to wait 60 seconds. Okay, this is an interview question. You need to remember, for learning 15 and for listening 15, then learning 15, as well as block 20 seconds. Okay, if any port is shut down, you write no shutdown, so then it will take 50 seconds. Why it is take 50 seconds? Because from block to learning it will take 20 seconds, then it will start listening, then it will go start learning, so it will take this much time. You need to remember 50 seconds it will take. And I shown you in the GNS3, when we power on the switch, it is learning, listening, then it is learning, and again then it will start forwarding. So what is listening, what is learning, we know that one, right? And if you want some theory, I can say in listening state, listening means he is listening. Here in listening state, you can say after blocking state, root port or designated port will move to the listening state. Okay, when we switch on, then it will move to the listening state. During the listening state, port discard the frame. So whatever frame this port is receiving, whatever port this port is receiving, whatever frame, he will discard, he will not forward. During the listening state, discard the frame from another port forwarded to the switch. So whatever frame we receive, it will discard. After 15 seconds, the switch port move from listening to learning. After 15 seconds, the port will move from listening to learning. And in learning, what we will say, if you want to write some theory for learning, you can say only root port or designated port are going to enter in the learning state after listening. Means if the port is blocked, it will not go in this state. Okay, if the port is blocked, it will not go in the learning state. Whatever port is listen, that port only going to be go in the listening learning state. Okay, so we can say Cisco switch port change to learning state after listening state. When they finish the listening from here, they will go to learning, and during this one it will take 15 seconds, and then after the learning it will move to the forwarding. And you can say in this state, switch listen and process the BPDU and use the frame, and this in the forwarding state, frame will be processed and it will forward to the whatever PC or whatever device you have, it will forward to that one in the forwarding states. And block state means whenever we put the port in the shutdown state, then it is a block state. It will take 20 seconds to move from block to listening and learning, like that. So 20 plus 15 plus 15, that is total 50 if the port is in the block state. If it is port is not in the block state, then listening and forwarding, then it will take 30 seconds. So you need to take. So with this one, what we are saying, like nowadays our PCs are very fast, and OSPF, EIGRP, this protocol are also very fast. Whenever you come to office, you will connect the PC with Windows 10, and it will, when you switch on the power, it will very fast. But because of STP, spanning tree protocol, this will take, if this port is just now connected, it will take 15 seconds for learning, and then again it will take 15 seconds for listening, 15 seconds, learning 50 seconds, that is 30 seconds it will take. So this is taking long time. To overcome these types of issue, we will go for RSTP, that is rapid spanning tree protocol. So rapid spanning tree protocol reduce the time from 30 seconds to less than 10 seconds. If we take normal spanning tree protocol, it will take 30 seconds, but if you configure RSTP in your switch, it will take less than 10 seconds. This is the main difference you need to remember. And we will say we have the types of STP. If you see types of STP, spanning tree protocol, what types we will have? We can say STP, and then we can say PVST, PVST plus, and then we have RSTP, and we have RS rapid, or we can say RAPID rapid, PVST plus, and we have MST. So this is open standard. STP is the open standard, and this PVST is the Cisco proprietary. Cisco produced this one, Cisco made this one. This is nothing but PVST only, but here we have per VLAN. This is P for per VLAN spanning tree, PVST. Okay, and this is rapid, that is open standard. This is also open standard. RSTP, that is rapid spanning tree, and this is PVST, means per VLAN spanning tree. Means if you have 10 VLAN, example you have VLAN 10, 20, 30, then we have spanning tree will be work separately for VLAN 10, separately we work in VLAN 20, separately work in VLAN 30. So 3 spanning tree will run in the switch. Okay, this one, I am going to show you that one also. So that is nothing but PVST. Okay, that is nothing but PVST. And RS, that is rapid spanning tree. It is also we have open standard. When we type this command, from the 30-second it will take 10-second time. And we have rapid PVST, that is Cisco proprietary, and this is nothing but same like PVST plus, but here we have time difference. Before this is 30 seconds, so here we will have the more less time. Okay, and this is Cisco proprietary, and this one is the normal RSTP is the open standard. And MST, that is multiple spanning tree, we are going to discuss that one also. This is also Cisco proprietary. No, this MST is, we can say this is open standard. This is open standard. Okay, so in coming videos we are going to check this one also. In the next video we are going to cover MSTP, but now we can see rapid spanning tree. Okay, so let me say some theory about the rapid spanning tree and spanning tree, then we are going to close this video. But remember, if anyone asks you, you can say types of STP is spanning tree protocol. We have one STP, we have PVST, we have RST, and rapid PVST plus and MST. Okay, and in next video we are going to discuss what is PVST plus, what is RSTP, this one, and like this one rapid PVST, and how we are going to configure in the switch. And after that we are going to discuss about the what we can say MST. Okay, thank you very much for seeing our video. Subscribe to our channel, share with your friend. Thank you, bye.